Welcome back to Uni Ironworks Shipbuilding 101, where we're going to be talking about machinery. This includes all the components required to power and fuel your ship. In front of us, you'll see the three different tiers of generators. This is kind of the primary means of producing electricity on your ship. There are batteries, and we'll get to those later. Technically, you can use batteries without the generators. But that's a little bit more advanced or maybe use case specific. Generator really only consists of two components. There's a fuel chamber, which processes the fuel, and a generator unit, which converts that processed fuel into electricity. You will need a fuel rod, of course. On the Tier 1 generators, they have their own fuel rods, which are the blue ones. And then Tier 2 and Tier 3 both use the Tier 2 fuel rods, which are the red ones. Now, you'll see a lot of these things floating around in space, causing all kinds of problems, killing space turtles. I recommend using these fuel rod racks over here. That way you can store your old fuel cells, store your new replacement ones. In the crafting system in the game, there's a way to recharge those fuel rods once they're emptied out. Now, each fuel chamber can support up to 3 generator units with the amount of fuel it processes. That means each one of these will operate at a rate of 100, whereas if I added a fourth one, they would operate each at a rate of 75 because they don't have enough processed fuel coming to them. You also need some interfaces for your electricity. So that's the red generator socket board here on the left, and it can attach to anywhere that's part of the whole generator, so the fuel chamber or any of the generator units that are attached. And then on the right, the blue pipe socket board is for cooling, and that is how you interface with the pipes. Cooling is a critical piece of the generator puzzle. If your generator is overheating, it will not produce electricity. So the fuel chamber itself produces heat as well as each generator unit. Furthermore, each generator unit produces additional heat for each other generator unit it's adjacent to. So in this example, these two units will not produce extra heat, but these two will because they're both adjacent to each other. The recommended way of cooling is the radiator because it's passive, doesn't require resources, it's relatively simple to set up. The generator or the radiator base will attach to a device hardpoint, which is piped and cabled, and then you can add extensions to increase the amount of cooling. The base itself is 90 cooling, and then each extension adds 90 more cooling to that. You'll notice there's orange tabs on these. If you face those to the inside, that's where the bolts are going to go on. We found you can attach up to 4 of these together. There's only 3 here, but if you do 4, the durability tool is going to yell at you a little bit. And if you'll notice, there's a little ridge here next to the base. If you go on the angle there, you can add 1 additional bolt, and that seems like between those 3 bolts, just on the innermost piece, is enough to get the durability tool to go back to green if you did have a 4th extension on there. Another mechanism of cooling is the generator cooling rack. Again, that can attach to either the units or the fuel chamber itself as long as it's part of the whole. And that takes cooling cells. The cooling rack will provide 300 cooling regardless of the amount of cells actually in it. As long as there's coolant in one of the cells, it'll function. And each cell has a capacity of 15,000, which will run out eventually. You do have the option of throwing a coolant recharge rack on a hard point somewhere on your ship. and that'll allow you to slot those cells in there and recharge them. It's just becomes a little bit more labor intensive, but it does have the added benefit of being a bit more compact of a ship design. Batteries produce electricity in the sense that they can provide it, they just can't regenerate it. There are some ship designs in the game that are battery only ship designs, well, in fuel, but those all require some other way besides generators of recharging those batteries. And I'll cover one of those ways in a little bit here. Batteries can store up to 10,000 units of electricity, and if you think about your power consumption as a graph, so you have kind of peaks and valleys and like a wave, batteries act as capacitors, and they'll kind of flatten those peaks and valleys out. So if you're just kind of cruising, then your batteries are probably just recharging. But if you're maneuvering or using your mining laser and all kinds of other stuff, you're going to drain those batteries real quick, and then you'll need to wait for them to recharge. If you were running a ship with no batteries and just a generator, and you exceeded your power generation, you'll end up with some weird behavior. Like, for example, your thrusters might turn on and off randomly just because they're not getting enough power, and then all of a sudden they are getting some power, and so on. Batteries are pretty straightforward. They have a socket on each side that you can wire, and they will attach together as long as they're touching. So in this example, I could cable this one on the bottom, and then all 6 of these would actually be attached to the network just with that one cable, since each of the batteries are actually touching each other. And here we are with our fuel, which are the hydrogen propellant tanks. The only real difference between the 3 sizes is the volume of fuel they can store. The input-output rate is 50,000 for all of them, which is more than enough for most size ships in the game. In order to build these, you really only need one of the support units. And there's where the indicator light is, there's sort of a cutout for that, and that's how they snap together. It's nice having both sides on just for durability issues, but technically you actually only need the one side. They do need to be piped and also powered, so you do need both connections. And they also provide a nice little control slot which you can throw a text panel on, or a switch, or whatever you want, if you want. Now, in order to refuel the propellant tanks, you'll have to either destroy the tank portion of it itself and slot a new one in, or you can refuel them through a resource bridge, which attaches to a hardpoint and needs to be both piped and cabled. The resource bridge does all kinds of things. This is just one of those things. But you'll see there's a state, which can either take the value 1 or 0. 1 just means it's doing something, 0 means it's not doing anything. Flow in, 1 means it's capable of taking in resources, 0 means it's not allowed to. And then again, for flowing out, 1 means it can output, 0 would mean it cannot output. So if I wanted to refuel my ship, or this tank, from, let's say, another ship, I would set this to flow in 1, but flow out 0. Oops. And then on the other ship, I would do the opposite. I would set it to flow in 0, flow out 1, and then this will start recharging with propellant from the other ship. And this also applies to batteries, so electricity can also flow through a resource bridge as well. Alright, the rest of this video is going to answer some of the questions that I had going through this process the first couple times, whether that was confirming values on the wiki or just playing around with these components just to see what happens. In front of us we have a tier 1 generator. This middle section is the fuel chamber, and then there's generator units side by side on either side of that fuel chamber. Now, each one of these components adds 100 heat. So this is a total of 500 heat. Except that it's really not, because each of these generator units is operating at 75% capacity, since the fuel chamber can only power 3 of them at 100%. So for 4, do the math, it's 75%. So what we actually end up with is heat produced this way. The fuel chamber is still going to generate 100, but the generator units will generate heat proportionate to its rate. Now, they're connected, which means they add heat. So according to the wiki, that's 25 heat going each direction. So you have to count it going both ways. Except that it's not really 25 heat because, again, they're operating at 75% capacity. So it's actually only 18.75. And now we have a more accurate picture of the heat situation here. So if we add all this together, so our fuel chamber is 100. Our generator units are 75, except for there's 4 of them, so we'll multiply that by 4. And then for each of our connections, so connections 18.75 with 4 of them, then add all this together. So we got our fuel chamber plus our generator units plus our connections. That's 475 heat from this system in total. Now in order to confirm that in game, we'll ramp up that generator to 100%. So unit rate is 100. And then I've got it independently attached to this radiator array of 7 sections. So 7 times 90 is 630. And the radiation rate is 75.396. So if we just take 630, so that's the amount we can radiate in total, and multiply that by 0.75396, that should give us the amount of heat that's being generated, as long as, of course, it's less than that 630 maximum that the radiator can handle. And if we round a little bit, that is exactly 475, which is what we came up with by doing the math from the wiki ahead of time. The generator over here is also running at 100%. Each of these generator units will run at 100% because there's just the 3, and none of them are touching each other. So this radiator that's independently attached to this has 5 sections, so that's a total of 450 cooling. We would expect exactly 400 heat out of this because each one is 100. There's 3 units in a chamber, so that's 400. So if we do the math on that, we would multiply our total cooling power or capacity by the actual rate of the cooling, 0.88888. And if we round, we hit that number 400 that we came up with just by taking a look at the generator. Both these generators are going to supply the same amount of power. The only difference is the heating situation. Having a 4th generating unit doesn't really, as far as I can tell, add any value. It just adds redundancy. Last thing I want to talk about is what happens when the radiators get super saturated. So here the generator is ramping up. This radiator is not going to have enough extensions to support the amount of heat. The extensions themselves don't have coolant, but the radiator base does, has a small amount of coolant. So you can see that right now it's at 150 out of 150. Now that we hit maximum radiation rate, the coolant's actually going to start to drain because the amount of heat being pumped to the radiator exceeds the amount of heat that it can vent. Alright, so now that the radiator base has run out of coolant, it's just going to sit there and try and vent as much as possible. And then the fuel chamber is going to sit wherever it sits based on the amount of heat it can vent. So in this case, it's between about 55 and 59 or so. And that's going to be the maximum it can run at until the cooling situation kind of gets handled. The supports attached to your propellant tanks have a default value called isOpenID, and on mine I renamed that to active, so my tank number active, and that allows me to tie it to a button. So here I have tank 5, now it's turned on, and that allows the ship to start drawing propellant from that. Earlier I said they had an input-output rate of 50,000, which is more than enough for the thrusters on this ship. So it's not really a necessary thing, but if you wanted to cascade your tanks so you didn't have to fill certain ones that were partially used or something like that, you do have that option.